morning, ladies and gentlemen. Welcome at the premises of Cyprus University of Technology for the public inauguration event of the Engineer Twinning Project. Engineer is funded from the European Union's Horizon Europe Framework Programme and the UKRI. Please be informed that today's event is being recorded and will be uploaded on our YouTube channel. Now, I would like to invite the Rector of Cyprus University of Technology, Professor Panagiotis Zafiris, to address his welcome notes.
I will be quite quick because I think the important parts of the program are coming up and it's not the welcome statements. But it's a very big pleasure for me to be here, and I would like to thank the coordinator Athos for inviting me to do this opening talk. We are here, I understand, for a twinning project, and this brings back a lot of memories because on the first cycle of twinning projects I did manage one of those, and it was a great experience and very fruitful experience. Twinning projects give the opportunity to people to actually come together, work on real projects, but mostly to network and build collaborations for the following activities after the twinning project, and I think this is the key activity that we will be engaging in. So meeting here is one of the goals. It will give you the chance to meet with our teams if you haven't done that in the past, see the city and enjoy the sunshine. We have a good weather coming up. I understand that the project is looking at cultural heritage and digitization of its resources. We understand that Cyprus is the right place to do this, and you have the chance to understand and experience the depth of culture that we have around us. Reading through the press release that was published a few weeks ago, I noticed that this project is bringing together 4 different labs from our very strong Department of Civil Engineering and Geomatics. It's also bringing into the project the Center of Excellence Eratosthenis, which is also going to disseminate the results of the project, and I think they have very strong potential. They were actually awarded as the best Center of Excellence in Dissemination from Cyprus a few weeks ago, and I think this is a guarantee of success. It's also bringing together 3 strong universities from what I read, and I would like to welcome the colleagues from Politecnico de Milano, UCL, and University of Aveiro in Portugal. I think this is a nice consortium. I would like to thank Constantina, who has been helping us for many, many years on this type of scheme. She would be the right person from our research foundation to actually support this project. I wish everybody great success, and we will be looking forward to your outcomes from this meeting, but most importantly from the project overall. Thank you.
Thank you very much. Now I would like to ask Professor Evangelos Agilas, Department Chair of the Department of Civil Engineering and Geomatics of Cyprus University of Technology, to address his welcome note.
Dear Rector of the Cyprus University of Technology, dear Officer of Research of the Promotion and Innovation of Cyprus, dear distinguished guests, dear colleagues, ladies and gentlemen, I apologize for my voice failure, but since this is my only available voice for the moment, I would still like to express a very warm welcome and a good day to all of you to the sunny Atlas Limassol after 4 rainy days. However, this didn't seem to be a serious obstacle for you, since, as I gladly heard, your yesterday's kick-off meeting was successful and you had an extensive and fruitful discussion. Our university, the Cyprus University of Technology, is a public university founded in Limassol in Cyprus in 2003 and consists of 6 faculties. CUT aspires to develop itself into a modern pioneering university able to offer high-level education and research in leading branches of science and technology which have high impact on the economic, technical and scientific sectors. In the same direction, our department, the Department of Civil Engineering and Geomatics, continues its efforts primarily towards qualitative education as well as pursuing the academic research excellence, while offering at the same time its services to the society both in national and international level. Our department offers 2 programs of study in undergraduate and postgraduate, both master and PhD level, with the respective curricula, studies in the direction of civil engineering specifically and in the direction of surveying engineering and geoinformatics engineering. In fact, we are the only academic department in Cyprus offering both these related subjects, and we are seriously looking forward to exploring ways of capitalizing in multidisciplinary research and excellence. We provide high-quality education and research programs in line with international guidelines, and we offer to our students direct engagement with industry, consultancy firms, and public bodies. Our graduates study and experiment in a dynamic and stimulating environment that allows them to cultivate a wide range of skills, helping them into their scientific and professional completion and their personal success in general. Still, we continuously try to further develop high-level courses, strengthening continuously our undergraduate and postgraduate degrees. Along with this vision, existing research laboratories under the umbrella of the CUT are teaming together for synergistic future research activities and innovation. In this direction, one of the milestones of the last years is the formation and operation of the Eratosthenes Research Center of Excellence, the first research center in Limassol with a total funding of around 50 million euros, which emerged from the European Research Programme Excelsior through our department. In the same way, through the present twinning funding, the various coordination and support actions and research activities aim to further enhance the unique alliance with 3 leading institutions from Europe. Engineer project is expected to fill gaps and set the basis for future collaborative research within our department. The project will capitalize on previous experience as well as on other still running projects. CUT members consist of a range of level of researchers with multidisciplinary expertise in the fields of geomatics and civil engineering. 4 research labs operating within our department, namely the Hephaestus Laboratory, the Photogrammetric Vision Laboratory, the Earth Observation and Cultural Heritage Research Laboratory, and the Geospatial Analytics Research Laboratory, are joining forces aiming to promote future multidisciplinary studies, research, and educational activities for the cultural heritage. The proposed research is anticipated to achieve a significant level of innovation and improve our excellence capacity in this specific domain. This will be accomplished through joint publications in prestigious review journals and international conference participations, while at the same time, and even more, it will allow our university to create stronger links with leading European institutions. Specifically, the Engineer project aspires to set out a credible pathway for the Cyprus University of Technology in the promising research and innovation domains of geomatics and civil engineering for cultural heritage preservation. For this vision, the CUT, through the Department of Civil Engineering and Geomatics, has aligned forces with 3 leading institutions in Europe, the Politecnico di Milano, the University College London, and the University of Aveiro. And the leading partners will work closely with us through targeted training activities, mobility actions, networking, and in-situ pilot research activities. At the same time, the leading partners will advance CUT's management and administrative skills. We will also promote scientific and industrial knowledge transfer to upgrade and reform CUT's system able to support future relevant regional and international requirements. The recently established Eratosthenes Center of Excellence, on the other side, will undertake the communication and interaction of the Engineer project with the local industry, society, and policymakers. This will maximize the impact of the project by creating strong links with entities of the smart specialization strategy of Cyprus. Also, the Center of Excellence, Eratosthenes Center of Excellence, will actively promote innovation, support commercialization and marketing services, increasing our university's technological maturity. And the project ambitions to promote research potential towards the better protection, management, and documentation of cultural heritage sites, assisting thus the local stakeholders. To report to some of them, the Department of Antiquities of Cyprus, the responsible authority for the cultural heritage of the country, and they will help them to make their goals. At the same time, it is expected to support engineers, small and medium enterprises, and policymakers to promote innovative solutions and state-of-the-art engineering approaches for heritage management. With the inclusion of the Eratosthenes Center of Excellence, which is a non-profit organization, the overall outcomes can have a real economic impact to the local society through the exploitation of the Inauguration of Excellence Digital Innovation Hub, providing the floor for potential spin-off companies, marketing solutions, patents, etc. This can support sustainability and after the end of the project as well. Building upon our unique character as the only university department in Cyprus where civil and geomatic engineers come together, the twinning project will fulfill and extend interdepartmental research activities using cultural heritage as the research domain. I would like to congratulate Professor Arapiou for this initiation and his big success. He is really a constant value for our university and for our department. I am confident that the engineer activities will enhance the research profile of our local team at all levels of researchers, increasing our attractiveness as a crossroad of research where civil engineering and geomatics are blended for sustainable development, monitoring and digitization of cultural heritage and its fruition at national and international level. Thank you all and have a nice day.
Thank you very much, Professor Akilas. Now I would like to call on the stage Officer Ms. Konstantina Magri of the Research and Innovation Foundation.
Dear Rector, distinguished speakers and guests, ladies and gentlemen, it gives me great pleasure to sit here with you today and welcome you on behalf of the Research and Innovation Foundation to the kickoff meeting of the Twinning Project Engineer focused on civil engineering and geomatics, innovative research on heritage. We are sure that the deliberations that will take place today during this meeting will further facilitate the achievement of the aims that the project has set. Cyprus is considered one of the most successful widening countries since the introduction of these measures under Horizon 2020, the 8th Framework Programme for Research and Innovation. Cypriot entities secured more than 88 million euros from the widening package, aiming to strengthen research and innovation activities and narrow the divide with EU counterparts with elite performance. The above-mentioned secure amount represents approximately the 30% of the total budget for Cyprus from Horizon 2020 funds up to today, showcasing the substantial contribution of the program for further boosting national and research and innovation capabilities. Speaking of achievements under the widening program, it is worth noting that the twinning funding instrument from which the engineering project secured funding attracted a great interest from the R&I community in Cyprus. A total of 23 twinning projects funded under both Horizon 2020 and Horizon Europe framework programs for R&I are coordinated by Cypriot entities, attracting total funding of around 11 million euros for supporting them on enhancing their R&I and networking activities with top-class leading counterparts. Considering this performance, as well as the lessons learned from our country's participation, we are confident that the Cyprus will have an even stronger presence in Horizon Europe, and we do hope that our research and innovation community will make the most out of traditional as well as the new widening instruments introduced under Horizon Europe widening participation and strengthening the horizontal priority. Focused on delivering high-quality services, the entities of the R&I ecosystem in Cyprus, RIF has an important mission. That is to support Cypriot entities in their efforts to successfully participate in Horizon Europe, acting as their partner throughout their journey through the national contact points. We would like to reassure you that all of our CPs will continue to offer their support and high quality services, so please do not hesitate to contact us when needed. I believe I speak for everyone at RIF when I say that nothing makes us happier than seeing proposals made by scientists, academics, and innovators in Cyprus receive the funding they need, and especially when they receive our guidance, which is the case for engineer team. On behalf of RIF, we would like to warmly congratulate you on this achievement and wish you all the best to your future endeavors. Thank you for your hard work and dedication, and wishing you all the best in implementing this interesting project. Thank you.
Thank you very much, Officer. Now I would like to invite Assistant Professor Athos Alabiou of the Department of Civil Engineering and Geomatics, who will introduce you to the engineering project as in his capacity as project coordinator.
Good morning to everyone, and thank you. Okay, good morning to everyone, and thank you very much for being here for the kickoff, the official kickoff of the project. So, dear Rector of the Cyprus University of Technology, dear Chair of the Department of Civil Engineering and Geomatics, dear Officer of the Research and Innovation Office, distinguished colleagues from Politecnico di Milano, University of Aveiro, and University College of London, dear colleagues, dear guests. It is with great pleasure that I welcome you also at the Cyprus University premises for the official opening event of the Civil Engineering and Geomatics Innovative Research on Heritage project with the acronym ENGINEER. This event marks the end of almost 1 year continuous effort to conceptualize, structure, draft, write, and submit on time a successful Horizon Europe proposal, following by other actions such as the preparation of the grant agreement with the European Commission, as well as the consortium agreement. The project, as stated in its title, it's built around the thematic priority of cultural heritage. It is well known that cultural heritage faces several natural and anthropogenic threats, including climate change effects. Innovative solutions and strategies are needed for better understanding, protection, and respect of history towards creating a common European identity. Engineer's idea includes EU policies and international conventions related to cultural heritage protection, management, and best practices, and is aligned with specific targets of the UN Sustainable Development Goals. The use of novel documentation geomatic technologies such as close-range photogrammetry and laser scanners have progressively been established in environmental monitoring. These technologies have significantly contributed to research and analysis over the past few decades in the domain of cultural heritage and landscape, particularly regarding archaeological sites and monuments. The potential use of geomatics technologies for the understanding, documentation, monitoring, and valorization of cultural heritage has been recognized by engineers, archaeologists, and public authorities involved in heritage management. The latest is demonstrated in the case of our project, as the Department of Antiquities of Cyprus has provided a detailed letter of support, and for this reason we would like to thank the Department of Antiquities of Cyprus and especially the Director, Dr. Marina Solomidou-Ironiou. This will allow us as a consortium to adopt a truly responsible research and innovation agenda for the engineering project. The idea of the project is closely connected with the smart specialization strategy of Cyprus. As known, the strategy was designed to pave the way for future sustainable development of the country, capitalizing on its unique characteristics and research ecosystem. Smart Specialization Strategy of Cyprus final report puts cultural heritage at the heart of the country's future development as a horizontal pillar, where other disciplines such as tourism, the major economic revenue streams here in Cyprus, and ICT, information communication technologies can interact. Today, it is well accepted that cultural heritage can act as an inelastic but also multiplier factor on which the future growth of our island should be based. As a multiplier factor of economic growth and social cohesion, the study and preservation of cultural heritage is expected to positively affect other pillars of economy, sustainable growth, and job creation. Engineer is a natural continuation of several past, ongoing, and hopefully future research activities of the personnel of the Department of Civil Engineering and Geomatics. Cultural heritage has been recognized as a central theme and field of expertise within our department from several colleagues and researchers. Indeed, the project, as also mentioned before, will capitalize and take full advantage existing knowledge and expertise of previous projects funded from Horizon 2020 framework, the Restart program of the Cyprus and Innovation Foundation, Interact actions, joint program initiatives, JPIs, and other local national funding projects. Examples of funded projects that the department has either small or more extensive role are the IMARE, MESTAC, Athena, Sarosi, Research, Ψηφιακό Αποσφράγισμα, Navigator, Periscope, Places, Ensure, Appliki, Gramit, Insight, Skouliotissa, Enkomi Masotos, Migrate, Riska, Unsula, Plisi, Mini, Klima, Protico, and many others. In addition, the project is expected to interact with other current Horizon Europe projects and initiatives of our university, such as the UNESCO Chair of Digital Heritage, the new Horizon Europe funded project Eureka 3D, and hopefully with other future advanced and mobility projects that are underway. But what new does the Engineer project brings to the department? Engineer is a 3-year project funded by the European Commission and the UK Research Funds with a total budget of 1.5 million. The project will take advantage the full range of the twinning core support measures. Throughout the time frame of the project, targeted summer schools, thematic workshops, online training, engagement with innovation hubs, and small-scale research projects are planned. These activities are designed to be open for participants and interested parties, maximizing this way the impact of the project beyond our department and beyond the consortium. Partners or individuals from the quadruple helix of the Smart Specialization Strategy of Cyprus, namely parties from the research or academia, stakeholders and policymakers, the private sectors, and actors from the society are expected to be involved. These entities will be engaged from the early stage of the research actions with participations in the coordination and support, training events, and knowledge transfer. The activities will be regularly updated and promoted through the project website and social media, so please stay tuned with us. The project actions are structured around 9 work packages, with the overall methodology includes 5 steps. As the only university department in Cyprus where civil engineering and geomatics engineers come together, the Twinning Engineer project is expected to fulfill and extend interdepartmental research activities using cultural heritage as a research domain. The project focuses on innovative research fields dealing with documentation, digitization, visualization, data exchange, structural studies, seismicity, seismics and conventional engineering of cultural heritage, including monuments and landscapes. The proposed actions of the projects aim to improve and enhance interdisciplinary skills, as well as to expand the research capabilities of the existing staff of the Department of Civil Engineering and Geomatics at CUT on issues related in the fields of applied geomatics and structural engineering for monuments and sites of archaeological interest. The project looks forward to the research and technological upgrade and excellence of the involved laboratories of our department. To achieve this goal, CUT has aligned forces with 3 leading institutions in Europe. Specifically, the consortium includes the Politecnico di Milano, the University College of London, and the University of Aveiro. All partners will work closely with CUT with targeted training activities, mobility and networking actions, as well as on-site applications, as mentioned before. At the same time, advanced partners will transfer to the CUT involved members expertise related to the administrative skills and current scientific and industrial knowledge. The final goal is to upgrade the ecosystem of the R&D of our department, capable to support future relevant regional and international challenges. A few words about the profile of our advanced partner. In particular, the Politecnico University of Milano is expected to provide support engineering regarding the recording, collection, analysis, and visualization of data through remote sensors, with the aim of geometric documentation and remote systematic monitoring of archaeological sites and monuments. The Department of Architecture, Built Environment and Construction of the Politecnico University of Milan is characterized by a strong commitment to the transfer of knowledge and experience while promoting innovative initiatives aiming at establishing new research profiles. The head of the research is Dr. Branca Tulsa. The University of Aveiro participates with the CISECO Institute, the largest Portuguese institute in the field of material science and engineering, with a strong infrastructure for characterization of materials, being a central point of the Portuguese network of electron microscope. The role of University of Aveiro is to provide support and transfer of excellence through the monitoring, material analysis, mechanical characterization of the structures, structural reinforcements, and conservation engineering. The research team is led by Dr. Alice Tavares, responsible for training UNESCO World Heritage volunteers for the protection and preservation of building heritage in Oporto, and is president of the Portuguese Association for the Urban Restoration for the Protection of the Built Heritage. The contribution of the University College of London to the project lies in the provision of support in the fields of structural and seismic and mechanical studies of heritage monuments. SEGE is one of the largest in the UK, with more than 50 active researchers covering a wide range of portfolio. The head of the research from the UCL is Professor Dina Dayala, holder of the UNESCO Chair in Disaster Risk Reduction and Resilience Engineering. We all have the chance to hear more about the advanced partners and get a glimpse of their relevant background in a while. Finally, the consortium is completed with the Cyprus Center of Excellence, ECOE. The center is a newly established research organization and is expected to undertake the communication and outreach activities to the non-academic audience. The results of the engineered project will be communicated with the local industry, society, and policymakers through the Digital Innovation Hub of the center. The role of ECOE is to maximize the project's impact by creating strong links with partners coming from the quadruple helix of the Cyprus Smart Specialization Strategy. ECOE will also actively promote innovation, support commercialization and potential services, maximizing thus technological maturity of project's actions. The general coordination from ECOE is undertaken by Dr. Kyriakos Themistokleous. On behalf of the CUT members of the project, I would like to thank all colleagues from the advanced partners for their willingness, patience, and enthusiasm to join this journey despite the difficulties. I do hope that this interaction will be also beneficial for all participants. Especially, please allow me to thank my colleagues, Professor Ferdon Kyriakidis, Associate Professor Dimitris Karlatos, Assistant Professor Nicolas Kyriakidis, the special teaching staff, Dr. Elias Gravanis, as well as researcher of our department, PhD candidates, Dr. Stelios Hachipetru, Marinos Vlachos, and the experienced researchers, Dr. Renos Botsis, Dr. Argyro Misantzi, and Dr. Vasiliki Sandrou for their support and efforts for a very successful project. Last but not least, our gratitude goes to the officer of the Research and Innovation Foundation Office, Mrs. Konstantina Makri, for her endless support and guidance, positive comments and suggestions. Without her support, this project will not be possible. Thank you, Konstantina. Engineer is a small step towards reaching excellence, and I am certain that the project will have a positive impact to the CUT and the department itself, as well as to all partners of the project. The kickoff is just the beginning of an amazing journey, and we do hope and plan other similar events in the near future. Thank you for your attention. Thank you very much.
So this concludes the first part of our public inauguration event. I believe it's high time to take a coffee outside and talk. Thank you.
We will continue with the presentation of the advanced projects.
So let's start with the second part of our public event. During this part, we will see presentations from the partners of the engineering project, showcasing our previous work. So, starting on with the Polytechnic University of Milan, I would like to invite Dr. Branka Kuka of the Department of Architecture, Built Environment and Construction Engineering to present us her work.
Good morning, dear officer from the Research Promotion Foundation, dear colleagues, dear guests of this event. For me personally, it is a great pleasure to be here. Today I will be presenting you Politecnico di Milano, that is from Italy, my third home country, being my first country, Serbia and Cyprus. So for me, it is actually a great pleasure to be back and to work together with colleagues from Cyprus and with colleagues from Portugal and UK on civil engineering and geomatics innovative research, research on heritage project that brings us under this same umbrella that is, let's say, cultural heritage, that for many of us is work, but for many of us is also passion, and I would say the values that we bring to also to our work. Today I will present to you a little bit Politecnico di Milano, our department, Architecture, Built Environment and Construction Engineering department, and the Politecnico di Milano team that is engaged in this project with some examples of our work. Politecnico di Milano is an institution of high quality training. We have 4 schools, and the members of our team are actually teaching in 3 of these schools that you can see here: architecture, urban planning and construction engineering, civil environmental and land management engineering, industrial and information engineering. Here you can see some numbers, let's say, in terms of programs that Polytechnical offers: 27 bachelor degrees, 44 degrees of master science, 4-degree programs with, let's say, in collaboration with other universities, 19 PhD programs, and so on. An interesting thing here would be also to note that Polyme offers 90 active MOOCs, that is massive online open courses, and let's say an interesting initiative in let's say distributing open knowledge further than the premises of the university. In terms of rankings, this is something that let's say is useful to mention. We are ranked in the top 13 in the 3 specific areas, in particular in engineering, 10th in architecture, and 5th in design. Another, let's say, parameter that is usually taken into account, let's say, of our universities, the graduate employability. This is let's say the information for 2022. It is ranked, let's say, 43rd. When it comes to resources and the results, the community of Polyme, again, you can see some data for the last academic year. It accounts for over 48,000 of master and bachelor degree students, and more than 1,500 PhD students. So we are quite a few people. Let's say, teaching to quite a few people. You can see the numbers here. I won't go through them, but just to tell you that it's a big community structured into 12 departments. Highlighted, you can see the Department of Architecture, Built Environment, and Construction Engineering that is mainly engaged with this project, but of course Polytechnic is participating as institution, so it will be our goal also to understand where possibly other colleagues are necessary to be involved, and where this could be this could bring the value to the engineer project. In terms of, let's say, infrastructures, Polyme has more than 200 research labs, 34 interdepartmental laboratories. So among these 12 departments that you saw, there are also the interdepartmental laboratories to, let's say, boost the interdisciplinary collaboration as well, and some 6 large infrastructures for testing and research. In terms of results, again, some numbers on Horizon 2020, Horizon Europe, and self-financing. Let's say one of the important aspects of the university is also the providing consulting services to mostly public entities, but also other entities that require scientific and technical consulting. In terms of research and business, there are 64 joint research centers established, let's say, within the Polytechnical, not to be confused, of course, with other higher level institutions, but they're research centers, let's say, within labs within the university. And another interesting fact that I would like to underline is more than 3,000 commercial agreements in terms of agreements with companies that Polytechnical is in fact collaborating with. Some information on the department that is involved in this project and the department that we are affiliated to: Department of Architecture, Built Environment, and Construction Engineering. We have something like 150 professors and researchers together, belonging to 20 different scientific sectors. In fact, one aspect, let's say, one characteristic of our department is that is a very multidisciplinary department, concentrating on one, let's say, we are brought together around one common topic, that is built environment and context. In particular, let's say, the topic that our group and our team can relate to most from the 4 areas that you can see here is the history, protection, management, and development of the built environment and landscape. So observing built environment and landscape under all its aspects. Here are some main challenges of the department. That is to say, decarbonization and climate neutrality of the buildings, regeneration of the built environment, digital and technological transition in architecture and construction sector, of course, innovation in the process of protection and development of cultural heritage, and technology transfer to developing countries. These are, let's say, here also to say that we are, let's say, fully in the vision and the mission of the department as well, together with activities of the engineering project. Here are some outlines and strategic lines of the department. I would also like to emphasize that as department, so ABC, the laboratory system, has 5 hard experimental units and 14 soft experimental units. This is a division that was made a few years ago, so recently, in terms of units that actually contain the infrastructure, let's say possibility for experiments, and then soft experimental units that are more focused on the let's say testing and software the implementation of the research tool, software use, and so on. Some numbers of our department. Since 2014, there have been some regional projects, national projects, European and international projects. This actually, and of course engineering is highlighted in one of the institutional slides that I stole from our department. Engineering is there already. It was also to highlight, let's say, the importance of the different scales of projects and funding perceiving. So we are aiming towards international, EU, national, and regional, all possible scales, and this is what we will encourage also throughout the project. We come to the core and engineer polymer team. The 4 main people that will be involved. It is myself. I will try to coordinate also with my colleagues, Luigi Barazzetti, that is here together with us, and Daniela Aureni, and Mattia Previtali, that unfortunately is not in Cyprus today, but we will see him in the months to come. We are, let's say, core partners, but of course, as I said, upon the activities that are outlined for us and that Polytechnical will undertake, we are already in contact with colleagues from administration, with the colleagues from technology transfer office, with other colleagues, specialists in the field that could be interesting, relevant, important for colleagues from Cyprus to see and to engage with. And a little bit about the team itself. What do we do? Well, first of all, I wanted to recall that we teach. We also teach, apart from this is a research project, but we also teach all the things that we do research upon. We perform professional survey on cultural heritage and landscape, and we perform research, of course, in the domains like data acquisition and processing, representation, and digital modeling at building scale, historic cartography for analysis and interpretation of territorial transformations, and open geospatial information and remote sensing also for cultural heritage and landscapes. Other topics, not to bore you with everything that we do, but these are extrapolated also, let's say, touching for in matching the topics that concern our teaching activities. And here are some examples of, let's say, practical examples of the work we do. Here you can see the Cathedral of Milan, Duomo di Milano. Whoever has been to Milan probably knows this building very well. Something that you might know is that it is suffering the subsidence effect, and actually what you see on your left lower corner is the simulation of the monitoring measurements over the past 50 years, and you can notice that there is some, let's say, relatively serious subsidence problem, but noticeable subsidence problems. Or other examples, to stay in Milan, we can also have a glance at the San Siro Stadium. You will be wondering why it is here. It's let's say, it doesn't seem to be related to cultural heritage, but maybe you don't know that San Siro Stadium actually dates back to the 1920s, 1930s, and let's say the way we see it now, it has actually been let's say updated. It has the third ring has been added in the recent years, in the 80s. If I'm not mistaken, it has caused some serious problems. This stadium is hence protected. It's a protected building. It's a protected construction, so important for the municipality of Milan. And it is suffering, let's say, due to its characteristic, that being a stadium and hosting large events, even concerts. I learned that this is the most, let's say, the most an event that could have the most impact on the operations of such sensitive structures. Here you can see the examples you can see are actually the examples of geometric surveying then put in service to further, let's say, further analysis. In particular, like for an example of Colemaggio, Basilica di Colemaggio in Aquila, in Italy. Maybe you have heard about this example. L'Aquila city was struck by an earthquake in 2009, an earthquake that was quite hazardous also for let's say human lives, but to the whole city, the whole historic city was evacuated, and Politecnico di Milano was called in particular to study the damages and to, let's say, propose models that could then help to understand the structure situation of the structure of the church itself that had suffered the earthquake. Here you can see an example of the technique that is, let's say, employed technique, pucci, that is to stitch and unstitch. So all of these elements, all the elements, but in particular the pillars that you can see here, have been, let's say, put down, constructed, so it was possible to actually follow their damage, and then they have been reconstructed together, but also virtually they have been represented in this way, so it was possible to actually go inside of the pillars and understand what is their composition and damage, and let's say to map this and to model it and to hence monitor this kind of damages to the whole structure. It is maybe interesting to say that the model of this church was then used for, let's say, with the colleagues, civil engineer colleagues, for the structural analysis as well. So we are going from the geometric surveying to representation to modeling to hence further analysis. Another example of this kind, so let's say we are considering the whole workflow of Castel Mazegra in Italy. You can see that it's a whole castle that has been scanned with hundreds of different scans connected together in the geodetical network at a different, let's say, levels of and different levels, a quite challenging project. That was then translated firstly into technical drawings, very fundamental step for our school, and then to the 3D models and HBIM, historic building information model, that can host both the geometry but also important historic typological information and materials and so on. All the important information that can, let's say, fuel further analysis. Another example of San Giacomo Church in Como with a similar methodology. In the cultural heritage, you know that no example is the same. It is always tailor-made, but our methodology and our approach is always, let's say, similar and adapted to the monument itself. We start from the geometric modeling to then obtain technical drawings and finally the model itself. And the last but not least, an example of open geospatial information and remote sensing for cultural heritage and landscape, and the case study of Albenga archaeological site, and the implementation of the observation, let's say, from the satellites, but together with the on-ground data of the hydrological risk in this case, because the case study that we dealt with was situated in the actual riverbed of Centa River. These, let's say, this information and further the yearly flights, for example, help the superintendents to actually track, not to protect, but to track the changes and to monitor the changes and hopefully to propose future protection measures that could protect this very, very sensitive site. So all these examples actually serve to, let's say, try to illustrate to you that we work a lot with public administration, with superintendents, with public institutions that need support in, let's say, from the surveying side, and that we need monitoring support from our side to better understand their monuments, to really have a better insight in their monuments, and to understand what could be the next step. So real kind of support. And to close, I go back to teaching. I would like to close with our students' work, just to tell you that all of this that you have seen, we transfer to our students. They are required to learn all these steps and to enter at least mentally in the logic of the surveying, and with the final product aiming to actually help the superintendents or whoever one day their client will be, or themselves, to understand better the building and its construction technology. So not only, let's say, it's not only geometrical information. The geometrical information is in service to the analysis of the historic construction elements, of the technologies, of historic technologies, and how these buildings were actually built, because sometimes we don't really have documentation on this, especially perhaps this is the case. This will be the case in many of the sites that we will tackle with with colleagues in Cyprus. I thank you very much for your attention. I pass over the word to you.
Thank you very much for this interesting presentation. Now I would like to invite next to me our partner from the University of Aveiro, Dr. Alice Tavares, who who represents Aveiro Institute of Materials.
Good morning to everyone. My compliments of the University of Aveiro to all of you.
Well, I would like to first of all say that we are very enthusiastic to share our knowledge, but also to learn from all of you. My colleagues that will take part in this project belongs to these research units and also departments. We try as much as possible to cover all the things that will be necessary, also to implement not only our key issues about materials, but also the part of structural engineer and seismic. So these are my colleagues. In fact, we work all the time in real case studies, so our research is used to fill the gap between what we see in the practice, because we also belongs to teams that make the design plans of architecture and civil engineer. So, and we also accompany all the builders that are in all of these spaces. So, in fact, we use the technologies and all the infrastructure that we have
for the collaboration with the institutions and also companies. One of the cases that we are at the moment working is under this cost action underground of built heritage, and we try as much as possible to bring other researchers from other countries to work with us and improve the way we can see the building, but also we can do to not to stop the decay and solve the problems. One of these are we call them Mamoa. That is in fact it is a dolmen, and we use all the research that we do at the university for this kind of reconstruction of in this case of the Mamoa. Is a boreal settlement, and in fact there are several problems, not only the structure, but also because of the guidelines that we have from our national institution about built heritage that oblige us to not touch, almost not touch in the monument. So we will try to, and it is in the moment in intervention. So we try as much as possible that our solutions solve the problems of rising down, of losing all the paintings that we have in these kind of monuments. And at the same time, we do the research for the materials, but also what are the necessary conditions inside, in this case, inside of the cave that can stop the cracks and can stop the rising down. And in fact, these are very relevant case studies, and we have also international researchers working with us on this. To achieve this kind of things, we need monitoring along almost 1 year to understand along the year what are the main problems related with environmental conditions, to also propose some measures of prevention before the intervention. We also develop along many years a specific research about adobe. What you see in this image are several types of the different moments of this. We have so constructions with sun-dried bricks that I already saw that you also have in Cyprus. And we try not only to characterize the materials of the different regions, not only characterize the mechanical characteristics and the physics of this material, but we also use real case studies. We dismantle, imagine we dismantle a house and rebuild again with exactly the same materials, and with the collaboration with our National Laboratory of Civil Engineering in Lisbon, we rebuilt and we use the acceleration, we use the shaking table, and we use the acceleration of strong earthquakes to see exactly the reaction of this kind of buildings. So we try to follow all the gaps that we identify and that are many times presented in many international research, and we try to have the solutions. This was a scaled model that we built at our laboratory. in fact, we don't have a shaking table, so we had to use other platform that could show the problems in an event of a seismic event or with the problems in at level of the foundations. After we understand what was the problem, we saw that the singular parts of the building collapsed. So we knew exactly what to do, and we strengthened all the structure and make the again. So, in fact, we are our main concern is to follow all the needs to present a practical solution in the time that we have, because sometimes we do the building assessment, and imagine we have just 2 months to do it, or 1 month to do it, and the builder needs exactly what are the guidelines to go forward. So we have different types of tests, from the materials to in situ tests that we also will well, at least will present to you when you will go to Aveiro or even here. And in fact, we have also another problem with the rising temperature due to climate change, because we at the University of Aveiro, we have a coastal lagoon with 45 kilometers long, and in fact they say that the level of the sea will increase, so we will have more problems about this in the future. The way that we do is not the only the characterization of what kind of salts that we have there and what kind of damage, but also what is the contribution of the environmental conditions. And we try as much as possible use real case studies, buildings that are not in use, and we implement the solutions that we test at the lab, because sometimes what we test in the lab in the real case study is not exactly the same. So we try, we do the research at the lab, and then we apply that in real case studies. And in fact, after that, we monitoring during 1 year, and to see if our solution solves the problem or not. And that is another kind of orientation that we follow. We also many times that several institutions call us, they need some guidelines of the intervention, for the intervention that are practical guidelines, but with the scientific base. So we do also several other documents or books. We also make a recreation of all the techniques like Adobe, and we try as much as possible work close to the communities, also to solve the problems of those communities in terms of the conservation of the buildings. I would like just to show you before. Just to show you, I don't know if no, it's not. So I need to close this. No. Okay, this is one of our labs. We have several labs in the same campus, so it is for us quite easy to go to one to another and to share the information. This is the lab of the civil engineer department, And in fact, one of the things that we would like is to have some real real case studies from Cyprus. Imagine that we can share our knowledge, not only what we do at our lab, but also to show you what are the capacities to use and to make this link with research, with the practice. And this is our main effort and the type of collaboration that we will share with you. Okay, thank you very much.
Thank you very much, Dr. Tavares. Now, moving on, I would like to invite our partner from University College of London, Professor Dina Diayala, who will show us her work at the Department of Civil, Environmental and Geomatic Engineering.
Good morning, and thank you very much for being here and for being here. So, and for having invited us, and thank you. We have seen from yesterday already that there is quite a lot of synergy in the work that we all do, and that there is a great opportunity for integration and collaboration and transfer. Just a very few words on UCL. We are a little bit older than Politecnico because we were set up in 1826, but the size of the the size of the university is more or less the same, about 14,000 staff, and 14,000 staff and about 50,000 students. So you can imagine that there is everything in it. So I will not go through the list of all the faculties and departments that we have, but what is important to highlight is that UCL was the first university in the UK to admit students that were not English, to admit students independently of their creed or their religion, and to admit women. So, and up to these days is still quite leading in the way in which access to education is provided. In this sense, you will see that and in fact, there are up to 150 different nationalities represented in our students' body, but also in our many nationalities in our staff. My presentation today is more about the work that we do within Epicenter. So this is not the full theme of Epicenter, but it's the people that are working more strictly on the theme of disaster risk reduction and resilience engineering, and particularly within this project, besides myself, we will have Dr. Yasmin Akhtar, which is a lecturer in materials and structural engineering, but also has a degree in archaeometry, so it will be able to also engage and let's say bring that contribution to the studies of archaeological sites that we will do. And then we have Dr. Rohita Dikari and Dr. Asana Vatteri, which are two research fellows, which are, yes, they were my PhD students before that, and they have quite a bit of expertise in structural, let's say, conforming building representations. And we will look a little bit more into that particularly. before going into more detail into the modeling, I would like to say that modeling of historic buildings is all, as both Brank and Alice have shown, starts with collecting data and getting the information that we need in order to know our object, our asset. And we can have different levels of data collections, some very, and depending on the scale also. So here, if we are looking at the urban level, we can have some very quick data, which will then relate to some very also, let's say, level of assessment or risk prioritization, but not really in detail assessment of the vulnerability and the risk. On the other hand, we can do a very detailed studies of one particular buildings, and we can arrive at much more detailed modeling. Or we can choose a midway level, which is sometimes the ones that allow us to get the full understanding, for instance, of the value of an historic center or an urban center, where we can collect all of a series of assets. And of course, when we speak about risk assessment, we cannot forget about the cultural heritage value, as the level of risk has to be commensurate, or the way that we mitigate the risk has to be commensurate to the value of the cultural value of the assets that we are considering. So just by way of quick example, so this is a project that we developed in the Philippines with the University of Santo Tomas, with World Bank funding. These buildings have been exposed to both earthquakes and flooding in typhoons in the year 2013, and it was a complex of more than 20 churches which were damaged across 2 different islands in Bohol and Cebu. And what we did was to define a way of identifying specific parameters that we could collect, so that, as you can see in these slides, so that we could come up with the distribution of these parameters across the sample of building that we were considering, and eventually determine what we call a vulnerability index, which had a nice and turned out to be a quite good log normal distribution, so that we could identify building in 4 different categories of damage, and therefore we could then move towards understanding the specific vulnerability of each buildings, then moving on to the local level of hazards in relation to the level of flooding, for instance, that was at the particular site. And once you have the hazard and the vulnerability, you can sort of compound them and understand what is the level of risk and the level of damage. So the inundation risk was, for instance, of a moderate high, but then the damage and the loss could be quite high if, for instance, at a lower level in the building there were particular elements of finishes or particular material which would be degraded by the inundation itself. A similar but a little bit more analytical approach. So this, however, allowed, of course, the quite detailed prioritization of the needs for each of these buildings. And indeed, this was done in 2013, so it's almost 10 years ago now. But I'm happy to report that in the intervening 10 years, the government in Bohol and the church organizations, because it's very much driven by voluntary donation in this particular case, have repaired and restored most of the buildings that were damaged. And this year, next year, they will actually have a celebration of the 10 years in April. On a different scale, but with a similar approach, if we are looking at seismic risk assessment of historic centers, so this is a work that we have recently concluded in Valencia, in the 19th century neighborhood of called Remey. We have looked at more or less 200 buildings there, with different level, again, of classification, historic, so we start from a cadastral base, the historical archive, the listing, and eventually the in situ data collections. You can see from the picture at the top there the level of difference of this building from an architectural point of view, so that it then becomes very, although they might all be 4 or 5 or 6 story high, but that the level of details of the facades and therefore the typology that you have behind, although constructionally might not be very different, actually in their response to the seismic action can be quite different because of the different architectural layout and design. So the approach here is to look at a number of them in such a way that we can cluster them in typology. So one cannot analyze 100 facades in detail, but yes, I can analyze 25 facades in detail. Yes. So that's the idea behind this. So we first collect data from 200, then we cluster them, we identify some recurring aspects, and then we apply what is simplified Pushover analysis to obtain what we call capacity curves. And then this is the bit that is particularly good. EC8 prescribes that we apply the N2 method. EC8 is the Eurocode 8 for seismic risk assessment. Prescribes that we apply the N2 method to understand the fragility of these buildings. So we can then, once we have obtained this particular type of model, we can do this, for instance, using a suite of natural recording natural spectrum, seismic spectra. We can then derive fragility functions for different level of damage and for different level of and for different level of the seismic actions, and then use that again at urban level, having done the proper seismological analysis of the area to define damage probability, the mean damage ratio, and eventually the damage built area. And these are the two extremes of the minimum and maximum damage built area for each buildings that we would obtain as a result of these studies. And again, here, having, let's say, start with a relatively detailed data collection, and then having gone through this process, we can go back and really look at each individual building and understand where the resources needs to be invested. Of course, the owner of the individual property might not be so happy, but that's a different matter. So now moving instead to, let's say, analysis of more specific buildings. So this is the Cathedral of Ica in Lima, Peru. This is a project that we did sometimes back with the Getty Conservation Institute. And what I want to drive through here is the necessity to looking at the models, when building finite element models, looking at the issue of the fact that we are not modeling concrete and we are not modeling steel. So the normal assumptions of continuum don't actually apply here. And for instance, in the case of this is basically a timber structure although it was very interesting because when we started working on this, we were told that it was adobe and the involved in timbers, but in fact, the whole structure is timber, the pillars are timbers, the arches are timbers, and it's then cladded in a little bit of adobe. So it was particularly interesting to find out. But also it was very important to understand that the timber arches were not continuum, were made of planks, and these planks were articulated with respect to each other, and you get very different deformability and deformation if you do or do not understand these aspects. During the same project, we were also looking at buildings in Lima. This is called the Comercio building. I think it's the most studied building in Peru. But again, we have the opportunity, and this is very relevant to both what Alice and Ranta were saying. It's very It's very important to do the opening up, to understand the connection within the individual elements, then go back to the labs and do tests that at the level of the structural element or the structural unit, which can provide you with the understanding of the structural behavior, then bring it into the finite element models, and eventually build larger model with slightly simplified assumption, but that take details of take in assumption the details that we are looking at. And again, another assumptions that it usually made when we do models of structures is that we have semi-rigid or rigid floors that we assume for the redistribution of forces. That's never the case in masonry structures, even if sometimes they have concrete slab. It doesn't quite work like that because the stiffness of the walls can be quite different and the stiffness of the element can be quite different. But also, because of that assumption, from a modeling point of view, it is not appropriate to assume the distribution of forces as is usually assumed for pushover analysis or for or for let's say displacement leg analysis, because not all parts displace of the same quantity. Therefore, we need to come up with slightly different approaches. And as we can see, for instance, in this model, although this is a whole structure, the deformability of certain parts is way, way greater than the deformabilities of others. And you need to take that into account in order to identify the real point of vulnerability and failure. One can do more sophisticated models with the finite element, and for instance, this is a model in Abacus for strengthening of structures using dissipative device, which is also devices that we have developed in our work with Syntax, where you can use what is called interface elements in order to simulate the lack of continuum between walls, for instance, and between friction. And Abacus allows to actually model and with these different scales, as you can see here. So in great detail, the element that we are interested in, but in much larger details, the other elements. And this is a simulation of the effect of the shaking of L'Aquila to this particular church, which is well, it's not really a church, the chapel of the Minimi in L'Aquila, which was for which we have proposed this particular dissipative device repair. And you can see how the device actually opens up and closes and limits the level of stresses that are affecting the two walls and allows the separation of the walls in a controlled manner. In a similar way, we can go from masonry to actually historic steel. And yesterday night, as we were working, I saw the old bridge that I think it's called the Four Lanterns Bridge, that separates the Greek quarter from the Turkish quarter. And I just thought about this work that we are doing in Chile for railway historic structures, again built at the turn of the century, so similar age of that project. How do I remove the sound? Yes, so this, as you can see, the bridge here simulates the model. No, I think you stopped the model. I don't know if you can see that. No, it's okay. It doesn't matter. So the bridge basically deforms at the level while the train is passing. And you can see the different deformation between when the locomotive is passing and the and then the various wagons are, and the fact that if we follow this type of deformation, we can understand the level of fatigue that brings to these particular elements, which are riveted as in earlier construction. And again, you need to get to the detail of simulating the local rivets in order to really appreciate the risk of fatigue after 120 years in use. We are also looking at ways of simulating the full collapse of buildings and integrating this with the flood effects. And this can be seen, for instance, here. Here you can follow up the loading, basically, and the formation of the capacity curves with the deformability of the different parts. This is confined masonry, which I've also seen around in Limassol, but the important thing is that we can actually look in great detail at the particular moment of collapse. Sorry that I cannot quite see the control here for some reason. Yes. So if we stop here, for instance, you can see, quite detailed the different strengths of the different walls, for instance, how they are deforming and how we will get to the collapse state. And we can do that with this method of discrete element method, where basically you simulate the bricks or stone independently from the mortar. If that's not possible with finite elements, and therefore it's very important, but of course you then need to get all the details of the capacity of the brick and mortar, and we go back to the material testings that Alice was mentioning. Typically, this is generally used for regular masonry layout, but we have also developed a way of modeling that allows for analysis of rubble masonry or not properly cut stones, which then allow to, for instance, in this case, clearly identify the area of weakness and how they collapse, simulating, for instance, two different directions of actions, or it can be simulated with Chinese reanalysis as well. just to finish a little bit on the environmental characterization of material and masonry, as we have mentioned that this is one of the strengths of our team. UCL is expanding in what we call UCL East, which is in a new campus on the ex-Olympic site in the northeast of the city. And there we have some very large laboratory of about 6,000 square meters, of which we have a number of resources that we can use for full metric characterizations of materials, and we have done quite a bit of work on that. Among the other resources that we have is this twin environmental chamber. This is basically made of two different chambers that sandwich a rig which has the capacity of mechanically load walls, both vertically and laterally, to simulate again seismic actions or wind. This is some very recent work that we have done on insulated cavity walls and waterproofing. And here we are also subjecting the walls to both to wind-driven rain. So these are some fans that produce pressure, and at the same time we have a system of rain water that provides that. So these are way of characterizing this. Unfortunately, there is no clear indication in the standards on how this should be tested, so we are also working on improving the standards in that respect. But just by way of conclusion, so what we can see clearly the difference between untreated walls, where we have up to 10 kilograms of water in just 2 cycles, increasing the weight of the walls while being absorbed. And when there is a very good treatment, then even after 8 cycles of the same amount of water, we can see that the actual absorption is much more controlled than in the region of very modest quantity. And we can correlate that with the RH, relative humidity and temperature sensors that we actually install into the wall itself, as you can see from here. And with this, I thank you very much, and we look forward to work with you on these themes.
Thank you very much, Professor Diayala. Moving on to our last speaker, I would like to invite Dr. Kyriakos Themistokleous, External Affairs and Business Development Officer of the Eratosthenes Center of Excellence.
Okay, good morning, or almost lunchtime. I won't keep you long. I'm between lunch and the presentations. My name is Kyriakos. I know most of you. We have collaborated in the past. I'm coming now from the Eratosthenes Center of Excellence, and just to give you a summary where we're coming from. Actually, we're coming from the Cyprus University of Technology. After 2000, we created a geomatics, remote sensing and geoenvironment lab department under the civil engineering. It was a laboratory that it was working from 2007. And in 2017, we decided that now we grew up. We got the knowledge that we needed, and we needed to get out and becoming an autonomous center. and becoming the Eratosthenes Center of Excellence. So we submitted a project under the team project, and we got the funding in order to do, to create a Center of Excellence. So the Cyprus University of Technology created that Center of Excellence for us, and now we are in a non-profit organization with our shareholders. The owner is still the Cyprus University of Technology, but we are autonomous in the sense of running the center. And now we are in the 4th year of this project. It's a 7-year project, and we are in the 4th year of actually creating the center, and not only that, but trying to be sustainable and running the research under the Eratosthenes Center of Excellence. The partners into the project, of course, the coordinator is CUT, the Cyprus University of Technology. Now the Eratosthenes is a partner into this scheme, and we have the General Aerospace Center in Germany, DLR. From you, a lot of you know about DLR. The National Observatory of Athens, NOAA. The German Leipzig Institute for Tropospheric Research, TROPOS, and the Deputy Ministry of Research, Innovation and Digital Policy of Cyprus. So this is the scheme of the project. The project is called Excelsior, as you can see from the top of the thing. A lot of people, they confuse Excelsior with Eratosthenes. Excelsior is the teaming project that is funded by the European Union, where the Eratosthenes is the Center of Excellence. Okay, we are funded, as I said before, 15 million euros from the European Union, and another 15 million euros from the government of Cyprus. And not only that, we have another 6 million euros that are funded from the Cyprus University of Technology. That this will be not only be cash contribution, but will be in-kind contribution in terms of buildings. We're creating now a new building. We're in the process of designing it. In 2 years, we're going to have a new establishment north of the Limassol in Berengaria. It's another site that the university is expanding. And the total budget that we have is about 38 million into the project in order to build a center of excellence and make it sustainable. The mission of the Eratosthenes is to conduct both basic and applied research towards improved understanding and management and monitoring of natural resources and infrastructure, and offer services and products in line with the latest development, remote sensing and related geospatial technologies in other high-tech tools. Our business is Earth observation as an umbrella, but not only Earth observation in terms of space, but we have Earth observation in terms of drones or in situ measurements and everything that is related to that. Under this, as I said before, our goal is to become a sustainable and become a world-class digital innovation hub, and for Earth observation and geospatial information. Not only in Cyprus, the goal is not to be a center of excellence in Cyprus, but our goal is to expand into the EMENA region, EMENA calling the Eastern Mediterranean, Middle East, and North Africa region, and in also Europe and internationally. Now, the thematic actually areas that we are working on, there are 3 different major departments that we structure: the environment, climate, the resilient society, and bigger data analytics. In the environment and climate, we have 4 thematic areas, which is the atmosphere, agriculture, water and land. And the resilient society, of course, we include the cultural heritage. This is something that we, as Cyprus, we own. We have 10,000 years of history here, and as you can see, we're really rich into cultural heritage. The other thing is the disaster risk reduction. This is something that also is related to cultural heritage, because most of the buildings we have are affected by earthquakes, a lot of geohazards and physical hazards that we have. Access to energy, marine safety and security, and the big Earth data analytics, it has to do with information extraction, visual exploration and visualization, crowdsourcing and data fusion, and geoinformatics. So we actually have a big area that we're working on. Other than that, we're trying to get into areas like access to energy, which is a big thematic area, especially in the region now, and not only in the region, but internationally. And now we can see with the war in Ukraine how energy is really important. Disaster risk reduction, water resource management, that we have a lot of problems here in the region. Climate change monitoring, that is affecting us, is affecting also cultural heritage and everything that we are dealing right now. And big Earth observation data analytics, that this is something that we're getting information, but this information they're getting large. We're getting from gigabytes to terabytes and petabytes. So this is something that we're working. And also now we got another twinning project, action like engineer, that it has to do with artificial intelligence. So we're working also on that. Other than that, just to explain a little bit the diagram on the right of the screen, other than that, we have another area, because here you can see the three departments that are coming from top to bottom, but we have a two-axis model that we're working with also in infrastructure. Most of the money that they're coming from the government of Cyprus, they're actually invested on infrastructure, and I'm going to talk a little bit how we invest that money later on. Research, as I explained, the 12 thematic areas that we're working on. Education, we are working with a joint program with the Cyprus University of Technology on masters and PhDs, and also skills development program and training programs that we can get even locally, or getting into the industry and trying to do capacity building, not only in the academic area, but get into the industry and the public. Another area, and this is something that we're working with the engineer program too, is the entrepreneurship. And this is about developing entrepreneurship mentality, because most of the times we have a lot of research projects, but they stay in the research area. They never actually go from research to product development. And this is something that we want to explore into the research center, and trying to see how we can develop products, not only stay on the research level, but trying to expand the TRL level and take them actually to a product level that they can get out in the industry. Next year, we're launching a program with the ministry, the Deputy Ministry of Research, Innovation and Digital Policy, that has to do with incubation. And what we're trying is to make calls, and not only that, invest to these companies. We're giving about 50,000 euros to every startup that is coming with us, and not only that, coming back, coming to us, get them incubated, and take them out, and and the goal is to be successful business in the market. This is something that is challenging, of course. You know that a lot of these startups, they're not, at the end of the day, they're not successful. But this is something that we need to work as Cyprus and as a center of excellence. Other than that, we have the living labs that we're creating, and with that, we're working a lot with the stakeholders in order to see different type of research opportunities that we can test in the market. And also we have the asset sharing policy that we can actually trying to use the infrastructure we have and use them with together with the stakeholders. Now, we are about 35 people right now, 35 staff. At the end of the year, in a couple of months, we're getting probably to 40, 45. At the end of the next year, 60 staff. By the end of the project, we have about 112 personnel. So we're growing a lot. We're hiring. So if anybody wants to come and relocate in Cyprus, we're here, and we're hiring qualified research personnel. As I said before, right now we're in the process of designing, with the university, we're designing our offices and research laboratories. And of course, we're investing into a state-of-the-art remote sensing and research infrastructure. You can see here we're investing in a big antenna that we can download images here in Cyprus. And we're working with the DLR for that. And not only that, but we're working on a ground-based station with LiDAR equipment and other meteorological equipment in order to monitor the climate and the atmospheric pollution here in the island. This is something that is also related with cultural heritage because a lot of atmospheric pollution is affecting the cultural heritage. There's a lot of collaboration with a lot of people. We have right now more than 600 collaborations internationally that we're working on, and these are some of our collaborators, including ministries, organizations, industry, and so on. A lot of activities, as I said before, they have to do with the atmosphere, with air quality, air pollution, aerosols, public health, monitoring for the extreme meteorological events, dust transportation, and we have a lot of programs, especially as you can see from the diagram here, dust that is transferred from Middle East, the Sahara dust from Europe and Asia, from fires and atmospheric pollution. And also we do rain rate calculations, and we belong into the Arteries network that we actually is a big network in Europe that we upload all that information that we collect in Cyprus. In agriculture, we're really active into this section, especially in precision agriculture, smart irrigation, carbon footprint, hydrogeological modeling, policy applications, soil health, pest disease control, food security, early warning systems, and damage assessment and mitigation strategies for extreme weather events. Water, again, water quality, water resource management, water leak detection, hydrological modeling, groundwater modeling, and so on. So we're not only on, in the sea, but we're an island. We're in the middle of water, but also on dams and any other water sources. Disaster risk reduction. Here we have a lot of work that we're doing with forest fire monitoring, burn area mapping, and saying that fire is one of the things that now is affecting a lot of cultural heritage sites and monuments. And this is something that we're trying to monitor, especially here in the island, that we have a lot of rich in cultural heritage, and trying to not only to be post-fire, but actually trying to do preventing catastrophic events. Systematic monitoring of geohazards, soil erosion, soil degradation, floods monitoring, epidemics and health, impact assessment, disaster management, early warning systems, and decision support systems. So this is something that, as you can see, is something that you're working on, as I saw from your presentations, and it's something that we are here to monitor. We're using a lot of space technologies too, including radar, SAR, persistent scattering, and so on, in order to monitor, all these disaster risk problems. Activities, as I said before, cultural heritage. Here again, we are active a lot in the protection of cultural heritage, especially, as I said before, with monitoring cultural heritage, root detection, cultural heritage digitization, and starting of excavated areas. We're working a lot with the municipalities, the Department of Archaeology, the Antiquities Department, and so on. And we're really active not only monitoring using space technologies, but in situ technology with digitization with drones, or ground penetrating radar with geophysics, and so on. A lot of other technologies that we are applying into this area. And the last, I'm not going to keep you long, there's a lot of areas, but this is the major areas that I want to cover, is the marine safety and security. That has to do with a lot with ship detection, bathymetry, wind, oil spills, and so on, that they have to do a lot with the marine safety and security. I would like to thank you and welcome to Cyprus. We're excited for this project.
Thank you very much. This concludes the public event, but before the closing remarks by our project coordinator, I would like personally to invite you to like us everywhere and spread engineering project activities. Thank you.
Okay, thank you, George, and again, many thanks for all of you for being here in Cyprus, especially those who have traveled from abroad. And we are closed. I don't want you to keep you anymore. And thank you very much again for coming here. Thank you.